temperature rating of the conductors in type NM cable is 75 degrees Celsius, which is equivalent to 167 degrees Fahrenheit. This means that NM cable is designed to operate safely and effectively when the conductors inside the cable do not exceed this temperature limit. Because of this limitation, you cannot run NM cable directly to a fixture that requires 90 degrees Celsius conductors. Using NM cable in such an application would violate electrical codes and create a potential safety hazard. The National Electrical Code, or NEC, specifies requirements for electrical wiring installations to ensure safety. One key aspect is the temperature rating of conductors and their suitability for specific applications. NM cable, commonly used in residential wiring, is subject to these requirements. When selecting wiring for a fixture, it's crucial to check the fixture specifications and ensure that the wiring's temperature rating meets or exceeds the fixture's requirements. If a fixture requires 90 degrees Celsius conductors, using NM cable rated at 75 degrees Celsius is not permitted. Doing so could lead to overheating of the conductors, insulation breakdown, and potentially a fire. To comply with safety standards and ensure proper installation, alternative wiring methods must be used when a fixture requires 90 degrees Celsius conductors. One option is to use individual conductors with a 90 degrees Celsius rating inside a conduit. Conduit provides physical protection for the conductors and allows for the use of high temperature rated wires. Another option is to use a different type of cable that is specifically rated for 90 degrees Celsius applications. These cables are designed with insulation materials that can withstand higher temperatures without degrading. When choosing an alternative wiring method, it's essential to consult the NEC and local electrical codes to ensure compliance. These codes provide detailed requirements for wiring installations, including conductor types, ampacity ratings, and installation methods. Proper wiring practices are critical for electrical safety. Using the correct type of wiring for each application helps to prevent overheating, insulation breakdown, and other hazards. If you are unsure about the proper wiring method for a particular fixture, it's always best to consult a qualified electrician. A licensed electrician can assess the specific requirements of the installation and recommend the appropriate wiring materials and techniques. They can also ensure that the installation complies with all applicable codes and regulations. In summary, NM cable is not suitable for use with fixtures that require 90 degrees Celsius conductors due to its 75 degrees Celsius temperature rating. Alternative wiring methods, such as using individual conductors in conduit or a cable rated for 90 degrees Celsius, must be employed to ensure safety and code compliance. Always consult the NEC and local electrical codes, and seek the advice of a qualified electrician when in doubt. The importance of understanding conductor temperature ratings cannot be overstated. Conductors generate heat as electricity flows through them, and this heat can affect the insulation surrounding the conductors. If the insulation is not rated for the temperature the conductor reaches, it can degrade, leading to shorts, ground faults, and potentially fires. The NEC specifies the maximum allowable temperature for different types of conductors and insulation materials. These temperature ratings are based on extensive testing and research to ensure the safety and reliability of electrical systems. When selecting conductors for a particular application, it's crucial to consider the ambient temperature, the amount of current the conductor will carry, and the type of insulation used. The NEC provides tables that list the ampacity of different conductors based on their temperature rating and installation conditions. Ampacity refers to the maximum amount of current a conductor can safely carry without exceeding its temperature rating. It's important to select a conductor with an ampacity that is sufficient for the load it will serve. Overloading a conductor can cause it to overheat, leading to insulation damage and potentially a fire. In addition to temperature ratings and ampacity, the NEC also specifies requirements for conductor installation. These requirements cover topics such as conductor spacing, support, and protection. Proper installation practices are essential for ensuring the long-term reliability and safety of electrical systems. For example, conductors must be adequately supported to prevent them from sagging or rubbing against other objects. They must also be protected from physical damage, such as abrasion or impact. In some cases, conductors may need to be installed in conduit to provide additional protection. Conduit is a rigid or flexible tube that encloses and protects electrical conductors. It can be made of metal or plastic and is available in a variety of sizes and types. The type of conduit used depends on the application and the environment in which the conductors will be installed. In wet or corrosive environments, for example, special types of conduit may be required to protect the conductors from moisture and chemicals. Grounding is another important aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and energize the circuit. This reduces the risk of electric shock and equipment damage. The NEC specifies detailed requirements for grounding electrical systems. These requirements cover topics such as grounding electrode systems, equipment grounding conductors, and bonding. A grounding electrode system is a system of interconnected electrodes that are buried in the ground. These electrodes provide a low impedance path for fault current to flow back to the source. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding electrode system. This helps to ensure that these parts are at the same potential as the earth, reducing the risk of electric shock. Bonding is the process of connecting together all of the metal parts of an electrical system to create a lower impedance path for fault current. This helps to ensure that fault current can flow quickly and easily back to the source, tripping a circuit breaker or fuse and energizing the circuit. Electrical safety is a complex and multifaceted topic. It requires a thorough understanding of electrical principles, codes, and standards. If you are not a qualified electrician, it's always best to seek the advice of a professional when working with electricity. A qualified electrician can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember, electricity can be dangerous if not handled properly. Always take precautions to protect yourself from electric shock and other hazards. Turn off the power before working on any electrical equipment and use appropriate safety gear, such as gloves and eye protection. If you are unsure about any aspect of electrical safety, consult a qualified electrician. The proper application of electrical principles and safety practices is crucial for protecting people and property from the hazards of electricity. Understanding temperature ratings of conductors is just one piece of this larger puzzle, but a vital piece nonetheless. Knowing that NM cable, a common wiring choice, has a limited temperature rating and when it is inappropriate to use is important. Firstly, safety is paramount. Using the wrong type of cable can lead to overheating and fire hazards. Secondly, code compliance is essential. Electrical codes are in place to protect individuals and property. Thirdly, performance is impacted. Using the correct materials ensures long-term reliability of the electrical system.